for success and professional development. Without further ado, let us proceed with our agenda. Today is the third day of our MATLAB workshop series. This session is based on the topic Introduction to Simulink, which will be useful to complete the final task. Moving on with the event's proceedings, we have our esteemed guest speaker to conduct this session. Without wasting much time, I would like to warmly welcome Dr. Vishakha Bastanayakan, lecturer at Department of Telecommunications at SLTC Research University, to conduct the session. Over to you, madam. Again, sorry for the delay. Madam?
Okay. Yes. Can you hear me?
Yes, madam.
Okay. If you cannot hear me, please let me know. So I think in the last class we have discussed about basics of MATLAB. So today I think we will continue from that point. So in today's, I will give a small overview of what we are going to discuss as well. In today's session, I think we will learn about how MATLAB is used for specific, plotting and for defining functions, defining scripts that can achieve some kind of a task. So we will discuss, initially we will discuss about how we can do coding inside MATLAB. So after that part, in the latter part of today's session, we will discuss about how it can be used for different, application scenarios. So we will try to, play with one or two apps or apps that are available in the MATLAB toolbox. So there are different apps that are available in the MATLAB software. So you can use those tools to, study data sets and so on. So I believe that since this workshop series is conducted in a way we try to, achieve a certain task. So I believe in your Python lessons, you have learned about the basics. Then you have learned about how you can do prediction and so on. So because of that, I was thinking about focusing on the data part in this session as well, so that if you want to see the data of certain signals or certain files, you can do that with different functions that are available in the MATLAB. So we will get into those sections step by step. So if you have any questions, you can let me know. Apart from that, as I think mentioned in the last session, you need I think an updated version of MATLAB to work with some of the toolboxes that I will be using. So if you don't have the latest version, try to install it. It might take some time to install this entire software. So I will try to demonstrate the installation process and record it and maybe provide it. However, as of now, I was not able to get it recorded. However, you will be able to find the process of installing from the internet, and you can follow the same procedure. So once you have the most updated version of MATLAB, you will be able to use the most updated functions and toolboxes that are available. So in order to get that advantage, I think you might have to install a recent version of the MATLAB. So in today's class, I will be using certain apps for analyzing, studying the signals. So we'll be studying some signals such as sound signals. So in order to analyze them, we will be using some specific applications. So we will be getting to that in that section. So if you don't have it installed or you don't have that app, maybe you need to install that. So yeah, so for today, we will be starting with the practices that you can follow when you're writing some scripts in MATLAB. So I think in the last session, we have discussed about matrix multiplication and up to that point. So I will also, try to, introduce some new functions and new methods while I'm discussing about the script writing process. So I believe that um, I can include some, ideas related to the main MATLAB basics while I'm explaining about the script writing part. So I will therefore try to first of all I will try to share a certain a code, a sample code that we can have in MATLAB and that can be used as the kind of the basic way that you can define a code in an organized manner in MATLAB. Right. So in this script, basically, I have started the script um, in MATLAB by going to first a new script option in here in the top left corner. So in there you can go to new and you can go to new script. So once you press that, you will be able to obtain a new script. So in here you can write a, a set of code lines that you can execute at the same time. So earlier we discussed about how we use the command window. So we wrote single codes in here in the command window and run them singularly, and then we watch the output. However, in this stage, now we are able to write several code lines at the same place and run the code lines together. So in the script files, we define all the functions or all the necessary steps that the code must follow, and we can see the output in the command window, or else we can observe the output as a plot. So that can be done. Apart from that, there's a new option or a recent option where you can go to new and live script. So this is an option that allows you to see the output on the right side of the code itself. So once you type something, you will be able to see the output appearing there itself. So I think we can define some kind of a um, vector, and if I press enter, I will be able to see the output on the right side of that code. Right. So I'm minimizing the command window space for the moment, uh, so that I can get this part kind of um, maximized. So anyway, I think I can try to improve the font size of the editor font by going into this properties editor in the home tab, and I can try to increase the size of the font under each area in the interface. So you can select the font sizes and you can select the size for each section. So, I mean, you need to select the specific section that you want to improve the font size in. So there's so that option is somewhere over here. So you can, I mean, you, we can find it. So sometimes I need to really find out the place for fonts. Go to fonts, custom editor. So maybe it is not functioning as I want. So as of now, only I think the font size in these sections have been enhanced, but these sections are still remaining the same. So if you cannot see the code, so you try to, yeah, in here actually it works fine. In the live editor, it does not get zoomed out. I think, yeah, I can just zoom out using Control Plus. So in here you can see the output appearing on the on the right side itself as soon as you give the enter for each line. So you can define each line and then you can get the output and you can see the output appearing in the in the right side uh, at the same time. So it is known as a live script. Right? So the normal script is like this, and the normal script does not show its output on one side. In the live script, you can type the code and you can see the output appearing on the other side whenever you give a certain command. So you can easily see the effect of each of the command in the live script. Right, so the live script actually has more animations than the normal script. So we will actually use the live script, I think, to check the different scripts that we are trying today, or different functions that we are trying today. So so anyway, like live script, I will keep it like this for the moment. We will get back into here later. So first of all, I would like to just explain about how we can write a code, set of lines of code in the script files. Right, so this is a sample code, and in here I have used the percentage sign to give the comment uh, of a line. So for commenting, I can use the percentage sign. Also, it is a good practice to give the title of a certain scripts and give the description of that script. Also, you can give your name. If you're writing the code, you can give your name as the author and maybe contact information. Most importantly, you need to give the date that you are doing the code, and you can maybe update this date as soon as you make some change, so that once you have different versions of the same code, you will know like what is the latest one. So you will it is beneficial for you to include details related to the last update, the date that you made the last update on the code. So after you have mentioned those details in the code initially, you will have to a way of organizing your code is that you can add 2 percentage lines to divide the code, and then you can give a small space and you can give the title of the new section that you are starting, right? So what I mean in here is that now you have started your code, right? You have started defining your topic and all the description. After that, once you are initializing your code, you can give two percentage signs and give the topic of the next section that you are trying to begin the code with. So initially, you will, most of the time, you will be doing initialization of the variables and the different parameters. So you will be initializing the different parameters and the variables. So you need to you can initialize that in this section, right? And then so you can define the different parameters in here. So depending on your algorithm, those parameters will vary. So for a certain scenario, you have to define the specific parameters here. And let's say you want to start a new section. Again, you will enter 2% marks space, and then you can define the algorithm that is related to your application. And then finally, you will be doing some analysis of the output of the algorithm. So you will be able to see the output as a plot, for example. So in order for you to see the plot, you will be able to do the visualization part after implementing the algorithm section, right? So in the visualization part, you can define the plots and whatever the uh, whatever the outputs that you want to obtain from the algorithm, right? So I think in the last class we have discussed about the main ways of defining different random random numbers and random vectors, random matrices. So continuing from that, we 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 can define um, lists of list of uh, uh, numbers using uh, using like command like this, where you want to define a set of numbers between 1 and 10 with a spacing of 0.5. So in here, the output that you obtain will be a certain vector that has values starting from 1 and ending at 10 and with a spacing of 0.5. So if you want to evaluate this, you want to check this output, you can highlight this, you can select evaluate section, and the output you can observe in this command window. So command window will show the output of the value of x, and it will show values of x within 1 and 10 and with some spacing of 0.5. And so there will be 19 values in this list, right? So 1, it will have so from 1 it will have up to value number 10, and there will be um, values up to 10. So since it's starting from 1, it is actually having only 19 elements. If I started from 0, I think there will be 20 elements in there. So anyway, if I want to evaluate, I can evaluate the values. Sorry, I can evaluate the values by highlighting and pressing evaluate section. So we can also define a set of values, values for a certain vector using linspace command. So linspace command is another command that can be used to define an array that start with a certain value and end with a certain value. So if my array or my vector starts with 0.5 and ends with 10, I can define it as like this: 0.5 comma 10 and comma the number of elements that I want to have between these two numbers, 0.5 and 10. So it's going to be 20. I want 20 elements equally spaced between these two values. So I will see whether there's an error or some output from this. So the output that I get is like this. So the output that I get is a vector, right? An array of uh, values that start from 0.5 up to and ends with 10. The number of elements that there is 20. So in cases where I want to define the number of values that I want to have between two numbers, I can use the linspace function, right? So, So if there are some cases where I want a fixed number of uh, values between two numbers, then I can fix that number in here. So as I said before, if you want some kind of a understanding about any function in MATLAB, you can go to help and you can type the function. So in here it's linspace. You can type linspace and you can find out its definition, how it can be defined in the standard manner, right? So it gives the explanation and it gives us what are these values, x1 and x2, and what is n. So the definitions of each of the parameters that should come inside this function is defined in this help. Once you ask for help linspace, it gives all the details regarding that function. So so linspace is also a function that you can use to create a vector, and this can be used to create a vector that can that has values starting from a certain value that is known and ending with a certain value that we know, and which has equally spaced elements between those two values, right? So if I define as 20 as the number of points that I want between the two numbers, the output vector will give me values uh, between these two numbers that are equally spaced inside the two limits, and the number of points that are equally spaced, and the total number of values will be uh, basically 20 values. So with regard to linspace, that is how linspace works. So, and then I told you that we can define uh, different algorithms inside. Uh, after we have defined our variables, we can define some kind of algorithm inside the algorithm section. So in order for us to get certain output from a certain from after we have some kind of input data, we can use uh, uh, either like separate lines of code, or we can use functions that we can define in the code, right? So we can use functions to obtain a certain output from our input data. So so we need to know how we can define some functions. So one thing to note is that in MATLAB, versions that were kind of old, or the previous versions of MATLAB had this feature where we need to define the function in a separate file. However, as of now, the functions can be defined in the same file itself at the bottom of the file, right? I hope it is was clear what I mentioned. So what I mean is that if you have any function definitions, you can define the definitions of functions at the bottom of your code, and then you can call those functions inside these sections, algorithm section or any other section in your code. You can call the functions directly into your code. So otherwise, the previous practice was that you have to define the functions in a separate script file and name that file as the function name. And then that function file needs to be in the same directory that you are working with, and then that can be accessed through our code file then. So however, now we don't have to separately define our functions. You can define the functions in the code itself, and then you can at the bottom of your code itself, and you can access that. So so we will actually now try to try to define a certain function. So in this part, I will be discussing about how we can define a certain function in MATLAB. So far we have learned about number generation and different ways of number generation. So now we have come to the stage where we are going to use a function to uh, compute something, and we are going to use the input data that we can provide. Right, the input data can be provided using some x and y variables, and once we give x and y as the input, we can get some output from that function. Let's say we are going to define a function called area, the function area, and then that can be calculated using a function name that we define. So when we are defining a function, we need to first give the keyword function, and then you need to give the output. The variable into which the output will be saved, you have to give it, and then you have to give the name of the function, and within brackets, you have to give the input parameters to the function. So you can give the values of the input parameters here. So length and width can be used to calculate the area. So inside in the next lines, you can define how the function should be defined. After defining the function, you need to end the function using the keyword end. So we will first end the function file with the end, so that that error is gone. So finally, once you're defining the function, you should define some value for the area. So area should be defined with some kind of a value. So 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 anyway, what should happen here is that the area is equal to the length into width, right? So it's basically that is the only function that is happening with the calculate area function. So we can actually consider other situations where the length and width are 0 or length and width are null values. So that kind of situations also can arise. So for the moment, we will see whether this functions in our code. Right? So function that we can define in here, we can define we can get some output. We give certain values into this as length and width. We will give 5 and 4. We see whether it works. Right? Before it is run, we have to also make sure that we save this file. So we have to save this file. So we can run this file now. There's an error that would appear in here. There's no error as of the moment. So the area is coming out as 20. So it shows that whatever the function that we defined as calculate area has been accessed by the code, which was defined at the end of the code. Normally, functions are defined at the end of the code. You don't define them in between lines of the code. So there's a specific area that it should be defined so that it runs smoothly. Otherwise, sometimes there could be some functions that are used in many sections of the code. So the compiler might not be able to understand the function and its behavior if you keep it in a middle point of the code. So once it is at the bottom of the code, the compiler can access that from the bottom basically and use it in anywhere it is defined. So regarding functions, that is basically regarding functions. So if you have like, I mean, very complex functions that also can be, defined. So the basic syntax for the function definition is this. So in here, actually, like this differs to the different function definitions in other programming languages. So basically for MATLAB, this is the syntax. And in here, you define the output directly in the function definition itself. And then you don't use any, semicolons or colons after the function definition. Then inside the, inside the area between function and end, you define the algorithm that is used to calculate the output of the function. So up to that, that was regarding functions. If you have any questions up to that point, you can let me know. Okay. So next, we will go into the next part, which will be plotting of the plotting of data. So we are going to plot certain data that we have. So for plotting, we can use 2D plots or 3D plots. There are many types of plots that are available in MATLAB. We can, I mean, basically categorize them as either 2D plots or 3D plots. The 2D plots involved with 2 axes, 3D plot involved with 3 axes. So so we will take some input data, and then we will plot the input data uh, as x and y axis data. So we will first discuss about the 2D plots. So when we have the 2D plots, we can use basically the function plot, the plot function to plot the output. So for this, you have to give the inputs to this function in a separate manner. So for plotting, you need to give x and y basically, which will uh, consist of the same dimensions, right? If you have x in certain dimension, y also should be in the same dimension, right? So as of now in this code, I have I have the same value that I have defined for x and y, right? So let's see whether I can try to plot this or not, right? Also, I need to also mention to you before, implementing this, plot function, I need to define the place where the plot should appear. So the plot should appear in a place where, which I define as figure 1. I can say I can index a number of figures, plot to the plot, and figure 1, plot xy. Then if I try to evaluate this, I will be able to get a certain plot. And actually, I had another plot that was going on in the system. So because of that, now my plot is drawn on top of that. So in order to avoid such kind of things, when you are initializing the code, you can initialize using these commands: close all, clear all, and then CLC. So CLC is used to clear the command window. Close all is used to close all the plots that you have open other extra windows that you have opened with related to the script. And then clear all is clearing all the memory values that you have in the memory. So memory of all the variable values will be cleared all once it is run. So so that is how we can close the previous plots and we can start new. So I think I will run this code and see whether there's an error. So if there's an error, it will be shown in here, and the output I get will be like this. So X values and Y values will be considered and the plot will be drawn like this. So first you need to give the X-axis value, then Y-axis value, and then you have to give the title. If you have a certain title, you can give that, and then you can give the you can give the so actually I think you need to check the standard way of defining this, right? So in different programming languages it's different. So in here in MATLAB you need to define the title in a separate in a separate command, right? So I will run this and see whether there's a error. So in here the title has appeared. If I have given the title in here as example, I think it will give a certain error. Let's see how it goes. Yes. So in here, it gives a certain error, right? So the standard way of defining a plot function is available through help plot. So help plot, and then you can see how the standard plots are defined. So first you give the X and Y values, X values, Y values, and then you have to give the color of the plot, right? So the color of the plot you can give, and the markers that you want to define you can give, and the solid lines that you want to define you can give. So if you want to change the line characteristic, you can define that using these values. So if I want to give that in here, if I want to make this magenta color, then I want to make it um, have maybe square and then have double colon. So it will hopefully it will appear like that. So it appears like that. So you can change the characteristic of this plot and the markers and the line characteristic using the command in here. The color, the line characteristics, the markers that you are mentioning can change there. So all the sample way of doing is given in here. So in the help plot. In the help plot, you can find the sample codes that are used to define the characteristic of the line. Right? There are other characteristics also. So as given in here, line width, marker edge color, marker face color, marker size you can define in here. So that also I will apply in here. So I can define the line width to be 2, which is that the width of the line, and marker edge color means that the edge of the marker or the outline of the marker will be K. K means black. Marker face color will be G, or the face of the marker will be G or green. So marker size will be 10. So we will run this and see how the output varies. So now it has changed, right? So the edge colors are black and inside color is green and the line color is magenta, right? Likewise, it has changed. So similarly, you can, try out with different features for the line plots, and after that you can obtain a line plot that you prefer, right? So apart from that, when you're working with the plots, you can add a lot of features to the plot, right? You can do that either using the code like this, you can add it using the code, or else you can add it using the property editor feature in this in this this plot. So in the plot itself, you can see that you can change the different features or the line. I mean, line width, line style. Those things you can change using this interface as well. So by setting the necessary things or the features in here, you can change the values in there. Right. So if you want to add the X label or X axis name, you can add in here. Right. X axis value. You can add it in here. Right. However, this can actually be added in the, in the using the code as well. So you can change the font size of the X labels, Y labels using the font size features. So for Y axis also, you can give some value, and the font size can be controlled from here. Font types, font sizes, those can be controlled in there. So so manually you can edit the plot once you get it from your script. So manually you can edit the plot as well. Right. So apart from that, you can add a lot of features to a certain plot. Right. So you can add grid, add a grid. Right. So grid on adds a grid to the plot. So once you have a grid, you can see exactly the points very clearly in the plot with the grid. And also you can click on the specific data points in the plot, and you can see the X and Y coordinates of each data point. So those coordinates also can be taken by clicking on the data points on the line. So apart from that, you can add a legend. So if you have multiple plot lines, you can add a legend to the plot. So a legend means uh, like a name that you're adding in here that corresponds to the certain line that you add in the plot. There are many types of output plots. Then you can differentiate those plots using this legend. We will learn about that in another simulation example. So for the moment, we will know that just using legend function, you can define all the different legends in here. So the different legends can be defined in here. So anyway, you need to have multiple plots to define the legend. Otherwise, the legend won't be able to, match the legend name to the plot that you have defined in here. Anyway, like if I want to give another plot in here, right, I can give a command called hold on, right? I can give a command called hold on, and then I can say that plot plot I can define the another plot, and I can define that plot value should be y squared. So in here I have done element wise squaring function that we discussed in the last session. So in here I'm going to give different values for the colors. So maybe green, no, maybe cyan color. So and some kind of other marker value, and then I can run this code and see how these both the plots are available. And also the legend, I can add a legend for the second plot. So we will run this. So is there output? Yes. So you can see that the legend has these two plots mentioned in the legend. Data 1 corresponds to the magenta colored plot. The data 2 corresponds to the cyan colored plot. So the legend font sizes that also can be adjusted using the code or using the property editor in the plot. So like that, you can define the plot in MATLAB. So that is regarding the plots. So you can add some more features into the plot as well. such as, for example, you can give the limits for the x-axis values, and you can give limits to the y-axis values. Right? If you want, if you prefer, you can do that as well. So it can be done using the limit command in the MATLAB. So you can give minimum and maximum limits for the x-axis values. If you want a positive, totally positive plot, then you can define the minimum value to 0 and then maximum value to 100. Then for y also you can give the same limits, right? Then let's hope that it will be able to capture all the values that we want to capture. So because 10 squared must be included in the plot. So with that, I think we will be able to give the definitions for the limits, right? So however, like since the limit of x-axis we have set to 100, then because of that the plot is not appearing over the entire space. We can give the limit of x-axis as 0 and 10 and give the y-axis limit as 0 and 100. So now I think it's back to the one that we already, I think, had previously, but now we have defined exactly the point where the plot should start and the plot should end. We can also start the plot with 0.5 such that the plot will be more spread. So we can say now the plot start from exactly from the origin or the place where the point is at 0.5 and the y point 0. Like that you can define the figures in the MATLAB. So this is about the 2D plots, right? And the 2D plots are like this, and you can define uh, uh, another set of plots in the same figure. You can define multiple plots. So we call that subplots. So we can also try to discuss about that also. So subplot commands are used for denoting multiple plots in the same figure. So in order to do that, I will take a certain example and then I will try to run that. So we will. So yeah. So this is the initial example that we have had. So now we are going to consider a new example starting from here, where I define x as this array which has values from 0 to 2 pi, and the values will be there will be 100 elements equally spaced between these two limits, 0 and 2 pi. After that, I will be plotting y1 as sine of x, y2 as cos of x, y3 as tan of x. So after that, I will be plotting each of these plots, y1, y2, y3 with respect to the x values using subplot commands. So subplot command. Okay, so the subplot command is actually a command which we use to define the specific position of the plot, the, the subplot that we have obtained. So in here, right, in here we have a 2 by 2 plot uh, that that is shown in the figure. So I will run this. We will see whether our plot appears, but it will appear on top of what we had, I think. But since it is subplot command, it has overridden the previous plot. So in here we can see there are 4 plots occurring in here. So all these specific plots are defined by one subplot. So under one subplot, we can define what is the x-axis, what is the y-axis, what are the values of the x-axis, what are the values of y-axis. We can define the title. We can define any feature for each plot. So similarly for each of the plots, we can define like that. So for for understanding, what we need to, like in here, what happens is that under subplot 2 comma 2 comma 1, we are basically defining this first plot, right? In this 2 by 2 array, the first one is the 2 comma 2 comma 1, right? And then we have then 2 comma 2 comma 2, right? So that, I mean, so this is just like the matrices. So we first go to the first element in the first row, the second element in the first row, and third element in the second row, and fourth element in the second row. So basically the indexing is happening in here as 1, 2, 3, and 4, right? 1, 2, 3, and 4. So there's like a 2 by 2 grid, and in that grid you are considering one grid by each instance. So first grid corresponds to the 2 by the subplot included in here, and subplot 2 comma 2 comma 2 corresponds to the cost plot, which is appearing on the first row and in the second column. This is the plot that appears in the second row, first column, and this is the final plot that is appearing in the second row and in the last in the second column. So each of the plots can be defined first using the subplot command, and then you need to define how the plotting should happen in that plot. After that, you can give a separate title, you can give other features, legends, other limits if you want, and you can define the features for each plot in here under the subplot command, right? So so the subplot command will work like that, right? So as of now we have that subplot command, and I mean we based plot, and so that will correspond to the sub plotting that we can add. Otherwise, if also if you want to add like a overall title, we can add that also. We can remove some things like legend and the limits, can add a certain common topic for the entire plot. Then we can see whether it appears, right? So sometimes maybe it is not taken as the output, right? So I need to actually define another figure. That is the reason. So I need to define a new figure that this can be plotted in, maybe figure number 2. Then in there, I think I can define the title. So figure number 2 has so okay. So I need to give the title, I think, separately in order to not to confuse with the subplot titles. So still this not available. However, I think we can specify that separately for the entire plot. So that can be done using a separate command. So we will try to run this. Yeah, so now we can see the example or the title for the overall plots using the command hg title. So a separate title function called sg title has to be used to give a common title for all the subplots that we define. So like that, we can define a subplot figure in the MATLAB. So for other, for other cases also, you can use the same kind of a template and you can define multiple plots in the same figure. So related to 3D plots, now we have discussed about the 2D plots. Related to 3D plots, we can have look at the syntax for that. So the syntax for the 3D command plots will be like this. So in here, actually, we have to have the third axis, right? We have x-axis values, y-axis values, and a third axis. So in here, I will define this figure as figure number 3. So in here, we can see, right? So once you define as figure number 3, it will actually correspond to the figure 3 that is appearing here. And then so that we can have a control over what figure the plot will be shown. After that, now we can define the x-axis value, range, y-axis range, and after that, uh, this surface plot will be generated based on x and y values, right? So, however, like we cannot directly say sine x, simple y, and we cannot directly equate that to capital Z or the output value. First, we need to create something called the mesh grid, which will be composed of values of x, and simple y that we have defined for the values of the x and y axes. So we have to use the mesh grid function. And in the mesh grid function, what it does is that the values of x will be repeated over all the rows. And the y value also will be repeated over all the columns. So we check how the x and y values are actually shown in the x and values are defined in the software once we use the mesh grid function. So we can see the values of each of the variables in MATLAB using uh, this, we can right click and you can type open. Then once you click that, you will be able to see something like Excel sheet. In there, you will be able to see all the values that is defined for that certain variable. Variable name will be displayed on top. Its size and its type will be also given on top. So x value is a vector that has values from 1 to 10.5. After that, y is variable that has values from 1 to 20. So that is how they are defined. Now let's see, after you do this function, what is the value of capital X. So since I already compiled this one, the values of capital X and Y are stored in the system. So we just right click, open capital X. In there, we can see that these values of X that we have seen earlier are repeated over all the rows, right? So the values that are there in the first row can be seen to be repeated over all the rows. Same value is repeated over all the rows. And then for the y, capital Y value, you can see that the value of y will be repeated over all the columns. Same value will be repeated over all the columns. That is how the mesh grid is created. The mesh grid is created. So after that, once we obtain this capital X and Y, we compute the sine value and the cost value or whatever the function that we want to compute on X and Y that relates the X and Y coordinates to the Z. So in here we have considered a function that relates the X and Y to Z, like sine X and cos Y is equal to Z, right? So we can do like this. We can do like this, where we define the relationship between X and Y using capital X and capital Y, right? So that can be done. So if we want, we can also add some more different function into this and we can see the output. Let's see whether there's an output. So there is some kind of output which is different from what we had earlier. So now it's like more, not that smooth and more like discontinuous. So some some discontinuous nature is there. However, like whatever the relationship that we want to add in here, we can add as the function that defines the Z value or the Z axis value. So we can define something like this, right? So we can define our function in here. After that, we can give the command surf to obtain a surface plot, right? To obtain a surface plot that combines the values into a surface, right? So in here we can see it is a surface, right? Right, this is a surface plot, and you can turn this around, right? You can use the turn around option on top. You can rotate using that option. You can see how the values of this plot is varying in each of these axis, right? So you need to actually give the x label, y label, those things, right, in here. So you need to give those values in order for the system to know what is the x-axis caption and the y-axis caption. So that you can give using some kind of, you can give it as x. Hopefully, all right. So you can see that x and y are appearing here. So it's very small. You can, define the font size of the x and y appropriately in here so that you can view the x and y coordinate uh, in a better manner. So anyway, you can define the titles for each axis using x label, y label, z label. Then you can define the, font size accordingly, right? So we can also check how the these functions work. So x label, y label, they are working in this manner. So if I want to give font size, I need to give the font size. So most of the time, I need to define it in a certain manner, otherwise it won't come. So it might give certain error. So we will see whether there was some kind of a, so I said axis, the font size has gone bigger. So you can do the same for the others as well. So most of the time, like, you don't have to remember these commands. You can, refer that from the help. So you can see X, Y, Z plot labels are appearing in a higher label size. So by that, you can define 3D plots. So basically, surface plots can be used or scatter plots can be used. Depending on your application, you need to, define the type of plot that you want. For 3D plots, 2D plots, likewise, you can define. So the scatter plots, if you want to define, it can be using the scatter command. So you can know the how it works using help scatter. So you can understand how it works using the definition. Okay, so there's some example command also. You can run them and see how it works. So I need to give a certain figure number, I think, otherwise I cannot really see. I have so I can give, okay, I can see the plot like this. So this is the scatter plot. So this is for the 2D case, right? Scatter T3 or the scatter 3 can be used for 3D case. So this is the 3D plot for the scatter function. So this is an example code. So basically, you need to define the place where the points should be placed, and that will be defined using the x and y coordinate values, and Z value will be defined based on those values. So you can obtain a 3D value, 3D plot using scatter plots as well. So there are many such kind of plots that you can use to, do 3D plotting as well. So that's regarding the plots. So we have discussed about the plots, the functions, and then we have discussed about how we define the subplots. So that was, I think, what we discussed so far. So, so there are other things I think that I want to mention regarding regarding the coding. So we discussed about the functions, right? So apart from the functions, we in this algorithm section, we need to use other methods to implement our algorithm. So we will be using if else functions, if else commands, right? So I think I will discuss about that now to complete the discussion about the basics and the understanding of MATLAB to develop an algorithm. So if you want to define an if else command, that can be done in MATLAB using this syntax. So first you can define, this is regarding initialization. So if you want to give if else conditions, then you need to first define if, then you can define the end of the loop using the end command. After that, intermediate cases where you consider else if or if else conditions, right? Where you consider different cases, then those else if conditions can be defined like this. And you don't need to put the space between else and if words. And finally, the else command is like this. So this is, once you compare with the other programming languages, this syntax has some differences. So in here, if you, like if you have X and then you have, if you have another condition that you want to check, then let's say X is smaller than 0. In here, you don't put the colon in here. And so apart from that, in other languages, you might see else if is defined like this, but in here you will get error once you do that. So if you have some kind of problems in your code, the MATLAB will show you that there's some error, right? So I have defined that colon here, is shown to be an error. And I have defined if, and I have not defined the end, right? So whenever I define if condition, I need to define the end so that I don't run into any errors. And then if I define else if, then I need to define the condition which I'm checking. Then I have to define the else function, which will be another important command to include in the if else condition case, if else condition syntax. So in all these cases, you need to define what needs to happen. So then in here, if I want to, check the value of X, I can use the fprintf option, fprintf command to print the value of the X, right? So if I want to print the value of X, I can print it using X value is, and then I can say the value of X. If it is a whole number, I can define the value of X to be a value which is of type D, and then I can define the new line using \n, and then I can define the variable that should go into this specific specifier that I have specified in here, right? So similar thing I can do for other sections also. I can give the same command, and then I can run this and see. So still I have some error in here because I have not specified some commands properly. Until I get all the red marks out of the system, out of the syntax, I don't know whether it's actually the correct algorithm, and it's not correct otherwise, right? So in here, so we can see, okay, so all the definitions that I have given, all the cases are identical. So avoid identical blocks to prevent unexpected behavior. So anyway, we will run this and see whether there's some error in this output or not. So anyway, it doesn't show any problems with the output. So the X value actually, right, X value has been considered. Now I need to consider X value in here as the X equal to 0 value, but in here I think they have considered all the X values that can be possible with the initial definition that we have given earlier for X in here. So because we did not clear the value of X, I still get the value of X as the previous one. So if I want to see the values of X, I can see the value of X, and I can see that X value is like something like this. It's a grid of values. So what I have done in here is that if the X value is below 0, that means the values of X, if it is below 0, then this one should be printed. So we can check whether what is the level that is getting printed. So we can, I think I can run this again. So the value number 2 is printed, which means that all these conditions are not getting satisfied in the algorithm, and only this else condition is getting satisfied. So that is, I mean, regarding the if else condition. So whatever the X value or whatever the variable that we are checking will be checked, and then if it is satisfied, that specific operation will be executed. And so when you use MATLAB, fprintf is the like printing. I mean, fprintf is one of the commands that you can use to print the outputs of a code. So I think that in any language we have this print option. So when you have a certain problem in your code, you can find the problem using this fprintf command, right? So if you cannot obtain some output at some point, you can add this fprintf command. And then inside the string, we define this specifier, and that specifier must be defined as a percentage mark and then D or any other specifier. So we will learn about the different specifiers that we can define in the MATLAB as well. So for fprintf, I mean for the if-else function, if-else syntax, this is basically the syntax that is used, right? So if you have any questions up to that point, you can let me know, maybe in the chat too. Or if you want to speak up, you can ask me directly, right? So I mentioned about the specifier, so we will discuss about that as well. So regarding the specifiers, right? So different, different types of data can be, I mean, uh, can be defined using this specifier. So in here, this percentage mark D means the integer values. The value of X must be an integer value for it to be represented as a integer value in here. So anyway, apart from that, you can also define the value of X as a floating number, a character, a string value. Those things can be used, right? So we will also, I mean, consider the situation where we are using this \n. If we don't use this \n, let's say I remove that and I run this, then I will see there's no line that is ending after each iteration or output. So in here now in the command window, right, there's no like ending for each of the output that I get for each value of X. right? So because of that, I will not be able to read the data very clearly for each element in X, right? That X is having many values, and X is having values like this. So for each value, after each value, there's no space that is added or new line added. So in order to add the new line, I need to add this \n. So that is how you can print the whatever the output in one line. So then after that, you can display, different types of data using fprintf, as I said. So if you have a string value and if you have a integer value, they both can be printed using the same printf, using this kind of a command. So in situations where we have a string value as, for example, name, and integer value as age, we can include that in this in the fprintf option, fprintf command, and inside brackets we can give whatever the string that we want to say, and then the string can be defined using %s, and then the whatever the integer value can be defined as %d. After that, we can end it with a \n and comma. We need to define the variables in the order that they are appearing in this specifiers. Right? So if I give the name first, then the name should appear here. The name will appear here. Age second, then the age will appear here. So if I don't do that, then the values of the variables will not be corresponding to the say specific format that we define here. So we need to make sure that whatever the specifiers that we define here uh, are defined, and then the order of the variables that we define in at the end is matching to the specifiers that we defined earlier. So that is regarding fprintf and about the different types of data that we have in MATLAB. So there are other types of variables or variable types that we have, like such as like apart from integer and string, we have character, we have floating number. So in cases where we have such different data types, we can use the specific specifier for that. If we have a floating number, we need to define that data format using percentage value and simple f, right? So we can run this, and the output will be shown in the command window, right? The output will be shown in the command window. So I told you about the live live editor. So I believe that it's better to go to the live editor to show the outputs. So we will go here. So in here, the outputs will be shown in the live editor in the other side once we click enter to this. So I think this is what we had earlier. So anyway, this should be run. It's not appearing. So we have defined 3 types of data, and then we are going to see the output in here. So I will, for the moment, I will try to reduce the size of the command window. And in here, I need to get all the whatever the things removed here. Close all. And then clear all. Then I can run this. So okay. So I need to check whether there's some kind of error somewhere. So I can start a new live script. Then I can copy paste this one there. So I should be able to get an output on the other side, but still it's not shown. Anyway, I will check about that. So for the moment, I think we will go ahead with the command window. So the command window, once you run this, we show the output in the command window. So the integer value, float value, string value, those are three different types of data. So integer values can be defined, specified in the string values using %d, and floating by %f, and characters by %c, strings by %s. So that is regarding data types. So the different data types are useful when we are trying to print out the outputs of a certain algorithm. So we discussed about the if-else conditions, and in there we try to print different types of data. So inside, after if-else conditions, right? After if-else condition, the most closest type of control structure is the while loop. The while loop can be also defined in a certain syntax. So this is the way that you can define a while loop. So concentrate on the lines of the code from 37 to 46. So the while loop, so this is the initialized constant. While loop is basically defined using while command and end command. And in cases where you want to break the while loop, you need to add the command break somewhere inside here. Let's say if the counter is above 3, let's say above 3, then break, right? So if the counter becomes above 3 or equal to and above 3, then the loop should break. So what happens is that the counter value in this loop is getting incremented during each iteration. So the counter value is getting incremented by 1 during each iteration. And the value of the counter is checked in here using the if loop and the if condition. Then if it is equal to or above 3 at one point, then it should break the loop. Let's see whether it happens. We will try to print the value of counter in here during this position to check whether the breaking happens at the correct position. So I will run this code, right? And then I can see that so whenever the counter value, so the counter value has been printed out in here as 1, 2, 3. However, if I try to comment this, right? So if I try to give certain break counter value, so I will be able to see some different outputs. So initially at each counter, the fprintf will print the value of the counter 1 and 2, and then at the break counter it will show the break value that was the reason for the break. So right at the point where the counter value is 3, the breaking will happen. So that is how the while loop functions, and that while loop will stop once we call the break command, right? So whenever while loop is running, and sometimes if there's some kind of a condition is satisfied, that condition will be considered, and if we have defined the break will stop the while loop at that point and will exit the while loop. So up to that point, we discussed about the while loops and if else conditions, data types, plotting, subplotting. So that is basically regarding most of the initial, necessary syntaxes in MATLAB. right? Another thing that I will also explain later is about the values of the variables, how the values of the variables can be seen in the variables tab. So as I shown you in here, we can see the values of each of the variables in this tab. Apart from that, once we are running the code, once we move our mouse to a certain variable, we can see the value of that variable. So that we will check. So up to this point, if you have any questions, you can direct them to me. So in the meantime, I will continue. So the TikTok is a like a function or a feature that we can use in MATLAB simulations. So basically, we can define a place in the simulation which measures the starting time of a certain algorithm. So if we define tick 1 as equal to tick, that means that this variable tick 1 will take the time, the initial starting time of the algorithm. And then at the point where we call the next function, which is the talk function, and once we call that, we'll be able to obtain the second instance of time where the algorithm in the algorithm. So the algorithm has several steps. So in the intermediate location, we can define a uh, talk function, and it can be used to find the time that was totally elapsed from the tick point that we defined up to the talk. So, the main reason for this feature, availability of this feature, is for us to understand what is the time that was taken to run this algorithm. Right? Sometimes in our simulations, we need to reduce the time of execution as much as possible. In such kind of cases, we can use this tick and talk functions to find the total time elapsed to run an algorithm. So I will run this code and see what happens. So in the first section, I'm calculating the total time that was elapsed from the line of code where the algorithm starts and up to the point the algorithm ends. And so I will run this. So the output will give me the total time that was taken to run the code, to run the code. Right, so the total time that was taken to run this piece of code is 4.409448. Right, so we can find the total time taken to run this algorithm. Right, then for parallel, I mean, another thing I want to mention here is uh, something called the parallel computing, parallel running of the code. So if we have a for loop, right? So I think I did not discuss much about the for loop, but for loop we can define in this syntax, basically starting with for and defining the variable that we want to have in our for loop, which is I in here, and the I value changes from 1 to capital N. Capital N is 100. So for loop can be implemented like this. And if we add the word par for, that means that there is parallel computation done for each of the loops. So there are some parallel machines running the for loop at the same time, such that the total execution time will be reduced. Right? However, if we cannot find parallel servers to run the code, then sometimes the delay could also be higher than the normal delay. So I will run this part. So this is about parallel computations and parallel computations in the for loop. Right? For the for loop, we can do parallel computations. So the output will show me the total time that was taken to run this code using the parallel for loop condition. parallel for or power for functions. The total time will be shown in here. After that, I will be able to compare whether the parallel for running is better than the normal for loop running or not. So so sometimes the parallel running might not be as efficient as we think. So that is regarding the parallel for loops and the normal for loops. Apart from that, we also discussed about the tick and tock functions that can be used to find the total time that was taken to run a certain algorithm. Right. So I'm waiting for the output from about this on this code that I have executed. So the total time that was elapsed has been shown to be 74.844, which is higher than what we had when we had like the single for loop to run. So sometimes the power for or parallel for loop running also can be delayed, and therefore it might not be that efficient. But in most cases, power for systems are preferred than the normal for loops. If you have several servers running, for example, I mean, when you're running this MATLAB script. So that is regarding tick and tock functions. So if you are worried about the codes that I'm using in here, I will share these codes in a GitHub repository, and I will share it with you. So I will share all the codes that I'm discussing in here in that repository. You can get them from there. You don't need to worry about having to remember any of the codes or any of the syntaxes that I mentioned here. You can see them. Once I share that with you, I will share that as soon as I can. And then you can, implement and you can test it on your own. So up to this point, if you have any questions, I would like to answer that. Right. So I think I have many things to cover. So regarding the code script writing, I have discussed in some up to some extent. So I will. I think I have completed up to some extent. Another thing that I wanted to discuss about the simulations in MATLAB is the Monte Carlo simulations. The Monte Carlo simulations is some simulation that we use to get the effect of random simulations that we are doing in different iterations or in multiple iterations. We are doing Monte Carlo simulations to assess the performance of our system under random instances, under random environments. So once our system parameters change with the random variables that are included in the system, we sometimes we will see different outputs than before. So in order to see those different outputs and capture all the different possibilities of the system, we use Monte Carlo simulations. So Monte Carlo simulations and its effect can be seen using this code. So in this code, we actually basically try to find the value of pi. So the value of pi we try to find by using a random process. So in the random process, if we use a lot of different random iterations and we check under, I mean, uh, like under number of iterations that we define, then uh, we are able to obtain a good answer if we run the random function multiple times. If we don't run the random function sufficient number of times, then the number uh, then we might not be able to capture the real real nature of the random process. In order to capture all the different all the nature or characteristics of the random process, we need to run the random function many times and then take the average, right? So that is known as Monte Carlo simulations. You run the system or you run the algorithm for many times, and in each of those times, random value will be created, right? So a different random instance will be considered, and at the end, you will be averaging all the different random situations, and you take the final um, you take the final value as the average of all the different outputs that you got earlier. So this is one code that explains that. So once I run this, it will give me the value of pi that I estimate using the random algorithm that I have defined in here. So this algorithm basically defines some random points inside a unit square, and then if the random points are inside a circle, then the points are taken as the number of points inside the circle are incremented. After that, the number of points are used to calculate the radius of the circle. So the as much as you do the random number iterations, then you will have more and more points inside the circle, right? So depending on the number of iterations, the number of points that are situated inside the circle changes. So if the number of points inside the circle are higher, then the final value of the estimated pi, or the pi value that we estimate, will be more accurate. So in the Monte Carlo simulations, what we do is we try to increase the number of random iterations that we are doing, and then we take the average and we take the final value as the average value of all the random iterations. Only then we can actually say we have considered all the different possibilities of the scenario, whether it be worst case scenario, best case scenario. So Monte Carlo simulations is something that you might need to be good at in order to consider the performance of your system. Your performance of your system that you're implementing must be robust to different random environments. So you need to test whether your algorithm works fine under all the different random situations. So in order to do that, we use the Monte Carlo simulation. So if we give the random iterations number to a low value, then the accuracy of my output might not be as sufficient as I expect. So the value of pi value that I get once I run that is about 3.2. The 3.2 is the value that I get if I make the number of random iterations to 10. If I make it 100, then I will be able to get value for the pi value, which is approximately equal to 3.24, which is a higher value than before, right? And then I can make it to 1000, and then I can run it. It will be equal to 3.09. If I make it to further than that, 10,000, then value of pi will be rotating around 3.13. So actual value of pi is 3.14, right? And some other floating numbers. However, we are getting there once we increase the number of iterations. So the accuracy of the output that we estimate keeps on increasing once we increase the number of random iterations considered for our algorithm. So that is regarding Monte Carlo simulations, and that is one example. This is another example where I consider the Monte Carlo simulations. So in this code, I define the Monte Carlo simulations and the number of Monte Carlo simulations by this variable, max Monte iterations. And in there, I can define the max Monte iterations up to, let's say, 3 or something. So let's say 3. And if I observe the output, the observed output, so I can see the code is still running. So there won't be any output as of now. So with the number of iterations, random iterations, the output will be defined. Its smoothness will be defined. So the output will look like this. So if I increase the Monte Carlo simulations iteration count, I will try to see some other plot happening. So this is the plot that I get now. So if you can remember from the previous instance, this is much better. Then 100, I will be having a plot under 100 that will be more smoother than before. And then if I make it to 1000, 10,000, I will be having a more smoother curve because I'm considering all the possible values that can occur in this random in random iterations. So I'm going to consider most of the random iterations that could occur, and then I obtain the data regarding those random iterations. Once I collect those random data or the data related to those instances, I can form a plot with more data included in it. And that is the reason that we am able to make a smooth curve. Otherwise, with less data, I cannot make a smooth curve. It will be discrete or it will be discontinuous. So when you're plotting something, you need to consider more data points in order to make it smooth. So if I have Monte Carlo simulations higher, or the iterations of Monte Carlo simulations higher, the higher you make it, you can make the smooth curve smooth, and you can make the output value more accurate. So that is regarding Monte Carlo simulations. So I believe that is also something important to you when you are working with MATLAB and even in other computing languages. In this point, I will also explain to you how we can actually debug a code using the debug option in MATLAB. Right. So in MATLAB, we have, like a way to debug the code and way to observe the values of the variable at certain point in the code. So let's say I want to check I want to check something in here. If I want to check the code and the value of the output that I get for a certain variable, I can stop the code at this point. I can do that by clicking in here, and there will be red dot. Then once I do that, I run this code, the code will be run only up to this point. The place where it stops will be indicated by a green arrow. And then whatever the value that I get for the previous variable will be shown once I move my cursor to that point. So the value I get is 1. And I can also check the values of each of the variables that I have. So C, SI, SO, rate, TH, those things I can see by just moving my cursor up to that point. Right? So for any variable that we define in the MATLAB, we can get the view of the values that are stored under that variable by going to that variable using the cursor. Right? So we can see the values that are there for that variable, by moving our mouse over there. And when we are in the debug mode, we can easily see all the values. Since we are debugging or checking the error of a code, we are allowed to see the values of all the variables that are defined in the code. So apart from that, as I said, we can also check the values of the variables by going to the certain variable and going to open, and I can open the value of variable inside the variables option. So under variables, I can see what is the value of outage SIS. So for example, it is 1 at the moment. So those values you can see in the sheet as well. And so anyway, like the debug option can be done like that. So you can debug means you can check the values of the variables until that point. And then if you want to give more additional debug points, you can also give like this. You can run the code and you can see the arrow goes to the next debug point. So if you want to remove any kind of a debug point, you can double click again on that, or click on that debug point. So so you can control the debug points. If you want to completely quit the debugging, you can completely quit it, or else you can define the debug points at any location that is there in the code where you can place a debug point. So these debug points are available only if you save this file with a certain name. So debugging is useful for us to know whether the values of the variables are actually correct in that point of the algorithm. Right? Sometimes it is not correct, and therefore, like some multiplications might not happen correctly, and there will be an error. In order to check those things, to check the dimensions of each of the variables, this is very easy. So in here, once I go near to a certain variable, I can see the dimensions of that variable. Its dimension is 10,000 rows into 25 columns. So that is the dimension of that variable. So that can be seen easily in this manner. So that is regarding Monte Carlo simulations. So I have covered up to Monte Carlo simulations, debug points, and seeing the variable values of the of the certain variables that we have in the system. So I think now we have done a lot of coding work and how we have learned about how the coding can function, how the code can function. So I mentioned to you that I will also explain to you about the MATLAB Simulink, right? So MATLAB Simulink is actually an environment that you can use to view a certain system. So you can access the Simulink by typing Simulink in here, right? Or else you can access the Simulink through the interface as well. So in home, you can go to Simulink option in here through
Excuse
that
me,
door. So
madam.
you can, yes. Yeah.
Someone from YouTube has asked if madam is saying about Excel or not.
Excel means like for what purpose?
The
Oh,
previous example was
uh, what do you mean by Excel? Excel means
thing he's asking about Excel Office. Is this was in the MATLAB or
no, it's not available in the MATLAB, but you can export the data to Excel file in the MATLAB. So you can create a Excel file in the MATLAB environment itself.
okay, thank you.
So I think we will do some example commands to generate the Excel file using the MATLAB commands. So before going to do that, I think I will explain about the Simulink. So the Simulink environment, I can start by typing Simulink in the command window, or else I can type the Simulink, click the Simulink in the interface, and then I will get a window like this, right? I will be able to see the, the models, or I can create a certain model in here. So I will try to give a small example, and I will try to create a small, environment. So, this is the place where we can build the model that we want. So basically in Simulink, you will be having a library where you have all the blocks that you need to create a system. So basically we'll have input data and output data you can create. So there are certain blocks that you can use for your model. So for this example, I will be basically looking at a case where I give a certain signal that I will modulate to a certain frequency, and then I transmit, and then at the end I'm going to demodulate it and try to decode the original data, right? So um, so in the Simulink you can find certain blocks, right? You can find certain blocks using commands that you give. If you want to generate a sine signal, you can type sine wave. Then you can drag it out onto the interface. You will be able to obtain that. You can like define the certain parameters of the signal by using this interface, and you can double click on that element and you can use this interface to give the parameters of the certain signal, sine signal, right? So this parameter, all these parameters can be set according to your requirements. Amplitude, frequency can be set. So Apart from that, you can also use some other, functions in here, uh, which are used to do, manipulations with the signals. And if you have, other areas that you want to work with, you will be having the blocks related to that area. For example, if you're working in robotics, you can find the different options in here. For example, PID controllers, the feedback controller. So those things can be found in here and you can search for those blocks in the Simulink. Then what you need to do is find it in the library and then drag it out onto the interface. After you do that, after you decide the whatever the inputs and the outputs of the system, you can connect them through arrows, and then you can get the output through a certain display. So that display you can find by something called scope. So you can get the output through a certain scope. So let's say this is how it is, and we basically we haven't defined anything like in this system. So by just connect it like this, I will be able to see the output from the scope, and I can run the scope. I can double click on it and I can see what is inside that. So if it runs properly, it should show me some output. So there are different ways to see the outputs. This is according to the time domain. And in the frequency domain, you can see another output. So you can get the spectrum analyzer to observe the output in the frequency domain. So this can be used to do the analysis in the frequency domain. Another option is the dashboard or dashboard scope. So dashboard scope, I can define the output or the place I want to obtain the output. Then I can see the output by running the code. So if you know the system, if you know the inputs and output of the system, you can drag and drop the blocks that you want, and inside you can define the parameters of that signal or the certain whatever the parameters related to that system you can define. So the spectrum analyzer also you can see. However, in here there's a certain option that says that spectrum cannot be displayed for continuous or infinite sample times. So since I haven't defined the sample time correctly, I do not get the values properly. So that is regarding how we can define the blocks in a certain MATLAB environment. You can compile it, and if you so you can get some output for each of the analyzers and scopes. You can adjust the plots according to your need. So depending on your application. So I think this is regarding the MATLAB Simulink introduction. So you can add other features into this Simulink connection. So I will share with you one of the examples that I have in my examples. So I will share that with you. You can run it if you want, and then you can see how it works. So this is one of the example codes that I have. I will try to run it. So Simulink takes some time to load, mainly because it has some kind of user interface and more user. specific details that shows. So because of that, the loading time is higher than the code. So the speed of the code is lesser. So if I take this code, I can run it and can observe different signals that are occurring at different sections of the code by adding some observation points into intermediate locations. So so this code is still running. It shows at the bottom that it's still running. So so up until it finishes, I cannot see the outputs. The outputs will be shown in each of the graph plots that I obtain at the end of the the file running. I can see the whatever the signal values in the specific domain. So these are spectrum analyzer plots. So the spectrum domain and the signals appearing in the spectrum domain will be shown in these plots. So that is regarding the MATLAB Simulink and how you can do the MATLAB Simulink simulations. So these are actually possible if you know the exact system of your model. Once you know the exact system model, you can create that model using connection of block components that do that operation. Right. So that is the basic understanding that I will be able to give you regarding MATLAB Simulink. So I think we have discussed up to MATLAB Simulink, and so we will now get into the section where we discuss about the things that I think we need to do about the data and how we can analyze some data. So if you want to um, if you want to get some data from a certain Excel file, I think one of the uh, uh, questions was that about the Excel file. You can basically put that into the directly into the directory with which we are working. Then you can use the data that is in that Excel file. Otherwise, we need to save that using a save command. And right. So you need to basically use the save command, and you can um, save it as Excel file in right. You can save it as Excel file, right? Or you can save it as like a mat file, mat file. So you can search for help and save, and you can save your variables as either mat file or CSV file or Excel file. So the format that you need to follow is given in this definition, right? So basically saving of a certain mat file you can do using save test.mat, and then afterwards you can so this is basically regarding saving as a mat file. Apart from that, you can also save as a certain uh, you know certain type of certain type of file. So save as function can be used to save images in different formats. So when you're saving CSV files, you have to use uh, uh, basically a different command, right? So that we can that we need to actually use this like default syntax to do that. So the I mean, depending on the variable that we have, we can save that. So if we consider situation where we have a lot of data and we want to save that data, I can save it as a mat file or then as a CSV file. So if I want to save as a CSV file, you can use the specific default syntax that is there for that. So, I mean, these syntaxes are something that you can find in the MathWorks website. So you don't have to, um, I think remember these commands, but these are some things that we can. So first we need to actually create a CSV file. So uh, we need to define, or we have to create a certain CSV file, and then we need to save the variable into that. So let's say this, whether this works. So I need to define the variable correctly. So if the variable is not a scalar, also there's some kind of a problem in here. So first we will try the scalar, and then we will try to save other types. So okay, so I will, I think, get into that. So I will, I think, show you some examples related to, I mean, saving the variable. So we need to initialize the CSV file first, and then we need to save the variable values into the CSV file. So so I think I will discuss about that. Um, so as of now, I think like I need to specify the command with that set of steps, and only that I can save the variable values into the CSV. So I will show you some example related to that. Um, so I mean, I was hoping to, after this point, to show you the uh, uh, a simulation related to signal processing, and use that data, and use that I mean data to create a CSV file. So I think we will I mean go to that section. So right, so if you have any questions, you can ask. So I need to go to a certain folder. So if I want to run a certain code in MATLAB, you must have seen that whenever I run a file in a folder which is different to my current directory, I will be asked this question. So I have to give the command change folder, and it will give me the current directory with which I'm working with, and I will be able to run the files that are there in that directory. So in this directory, I have set of files, and I have set of data files that I have previously uploaded into this section. Um, so I will be discussing about those signals and how to work with those signals now. Right, so we will be looking at an application basically, and we will be trying to analyze the signal in that application. So, so I will be using an app called Signal Analyzer app, and I will, go to that app. So currently I have it already opened. I will try to close it. So the Signal Analyzer app allows us to see the behavior of signals and allows us to separate out certain components of a signal and do filtering on the signal and other uh, you know uh, processes on the signal. So if I have if I have some data signals in the workspace, I can obtain them and I can view them in this app. So I think this is one app where I can see all such data. So if I take, for example, one variable, I can see the signal and how it is, behaving in the time domain. And I can see its output in the spectrum or frequency domain as well. So likewise, we can obtain certain, plots for the certain signal that we are trying to analyze. So we can see the frequency variations of the signal, and then we can see how the frequency, components are there in the spectrogram. So this is how a signal analyzer looks like. So what I'm trying to do is that we are trying to analyze some sound signals that are available with a whale, an animal, the whale, and we can actually see some patterns in the whale sound. Using that pattern, we can see uh, like what are the different areas or regions of the of that of that whale sound. So I will run. So this is the platform that you can use to just analyze the signal, um, and this is also used to do add some filters, low pass filters, high pass filters, and only capture a component of the signal. You can add, capture a component of the signal using certain filters that are available here. So that also I think we can discuss. For the moment, I will close this and I will try to run some sample code in here, which would enable me to load some data into this workspace. So already there's some, sample data available in the MATLAB that I want to load, and that I will load using the load label whale signals. So already MATLAB has some label data that has two whale signals, whale sound signals, and those sound signals are labeled as whale sounds, and they are sampled at a certain frequency and their values are obtained. So I will run this. I will try to use the live script. Hopefully now it is working. So earlier it was not functioning well. So I would like to run it and see this time. So if it is running, it should be able to I should be able to see whale signals in my directory. So first of all, I think I will clear all the directory variables in order to clear the variables that I have currently, and then only obtain the values that are related to the label whale signal file. So label whale signals is a mat file that contains values related to whale sounds. It has two signals, whale 1 signal and whale 2 signal. So apart from that, some other information is also there in the whale types variable. So if I want to analyze this signal, I can do that in the signal analyzer app, or I can do that in the signal label app. So I think labeling is something we require in the machine learning world. So we need to label the signals. So for that, we can use signal label app. So earlier I was discussing about signal analyze app. It's also another app, but for labeling purposes, we can use signal labeler app. If I want to obtain the variables that are there defined in the workspace, I can go to import and I can select the variables that I want to import. Then I can select if I want to work with time domain or sample domain. If I want to work with time, I will define as time. Then sample rate I can define as the sample rate at which the sound was sampled. So it is something known to me, or I can define a very high sampling value, and then I will be able to get the signal without any problem, without losing any data. So once I import the signals, I can observe the signals by clicking on this check button. Then I can see how the signal looks like. So the whale sound looks like this, right? So the whale has a, a place where it makes a very high pitched sound, and this is known as the trill sound. So if I plot the frequency domain, where the frequency domain signals are also shown in here. So if I see the frequency domain, as per the frequency, the components that are available in the signal are given in here. So for a certain time instance or for a certain frequency, the highest frequency that it can be observed is this place where the 0.5 kilohertz signal is appearing. So the whale has three main regions where it has like high amplitudes. So the place where it has a trill sound is the place where it has the high pitched note. Then in these intermediate locations, or like in these locations, these three locations which look similar, they are known as moan region. So we can run this file, run this, whale files, and we can check the sound of the whale file. Whale files, I can check the sound. So I believe I will have to share with the sound. So once I run this, I will be able to see the sound of the whales. Okay. So you must have heard two different sections in that sound. So in that we heard like one part where it is high pitched and three other parts which are kind of low pitched, but they are similar. So those regions are trill region. This high pitch region is trill region, and the low pitch or somewhat medium range pitch is belonging to the moan region. So normally whales, they are making this periodic signal, right? So every time once there's a trill, there will be three moans that are occurring. So using this, we can predict whether there's a whale in the environment, uh, and we can also predict uh, at the time instance when the moan sound will come. So if we have the data about the trill happening and the time it happens and the time the moan happens and the distance or the time difference between the gap between the moan regions, then we can know at which location the moan sound is occurring. Using that information, we can say, okay, at this point, the whale is making this noise or making this sound, and then at another time instance, they will make another moan sound, or likewise, you can determine. Using that, we can make predictions about maybe the health of the whale or some kind of condition about the whale's sound. So for that, I think we can use the signal labeling app. So we can label the signal components and we can save the labels of the signal components according to our requirement, right? So if we want to label these components, we can first create some labels. So we can add a label. We can actually do different predictions. So I will try to explain about how we can define different types of whales. So different types of whales can be defined as well. So whale types, it's an attribute regarding the signal. So we are saying the whale type. So it's an attribute regarding the whale. Then you can say categorical. That means like out of three categories, you are defining the type of whale. So there are different types of whales. You can define the whale type in this categories. So there are mainly, different types of whales. You can find the sound signals of those different types of whales, and such kind of sound waves also can be used to differentiate the blue whale or humpback whale and white whale with each other. So sound signal they are generating might have some differences. Using that, you can differentiate the type of whale. Then you can define a certain optional value for this. Otherwise, you can define it later as well. And then, so I will define the optional value as blue whale, and then I can say okay. So I can add some more labels, which is moan regions. So I'm going to select region of interest by selecting ROI, and then I'm going to say logical, which means that I'm going to say whether there's a moan here or not. This means true or false, which means that I give the label that the moan is there in that location in the signal. So yes or no is the output that I'm giving regarding the moan presence. After that, I can define the moan region in the signal itself. Before that, I will also add another label, which is trill regions. Trill regions, which is another region of interest that also I can define as either true or false. And then I can define a sub-label, add a sub-label, which is trill peak of the trill, right? Trill peaks. That would be a point in the signal that also can be either true or false. And I can just have a labels like this. So I can label each part of the signal and I can relate that to a certain time instance. Right? So during this time instance, the moan is happening. So this is a trill. So this is the trill region. So if I want to give the trill region, I just select the trill regions and I give the region that I think is the trill. So by doing so, I can define the trill region and I can define the moan regions. I can define all the moan regions. So that is regarding defining the regions. So if you want to specifically like exactly point out the moan regions, then you can use the other options where you can zoom out a certain part of the signal and you can test whether you have added the moan signal correctly in that region. I mean, you have correctly defined the region. You can check that. So um, you can actually change the width of any of the regions using this option here. You can increase or decrease the width of the region. So by doing that you can exactly point out the different regions of the signal. So the labeling you can do for the signal sections that we have. So this is how we can do some kind of labeling for one. So this is the one sound signal. Same thing can be done for the second sound signal that we have, right? So after doing all that, we can save this and we can export this back into the workspace or as a file to a mat file. So we will we will export this as whale songs, right? Whale songs, and I will so I will go back to the MATLAB. I will be able to see whale songs mat in here. Once I click on that, labeled data will appear in here, right? So a data that has some labels associated with the original data, it will be here. So we have this matrix that has the labels and the remaining data related to the signal. So related to the whales sounds that we had, whale 1, whale 2, we have defined the type of the whale. We have defined the type of the whale as blue whale. And so we can change that also if we want. We know the correct type of the whale. We can define the correct type of the whale using this option. After that, since we have actually defined the moan regions and trill regions for the whale 1 signal, only those details are available here. So once you click on that, you'll be able to see the time instances where the moan regions are occurring, right? So you can have this this data. And this trill region is also that data is also available here. The time limits where the trill region happens. So those are actually inside some other tables that are inside the main object that has all the informations about the these sound signals, and they are actually defined in this label signal set. So so you need to actually go inside and you need to find the necessary data by accessing these variables. So to do that, you can either access the variables using the code, you can access this using the workspace that is available here. So if you want to create a data set, right? If you want to create a data set, you might have to consider this Excel sheet kind of a, this, uh, this, I mean, format, and then you can copy paste directly from here to Excel sheet, right? So if I want to have this ROI, limits, and I want to copy to a like Excel sheet, you can directly copy into the Excel sheet. So to the whatever the location that we want to, copy paste, I can directly do that from MATLAB to the CSV file. I mean, just manually. I mean, because it is already available in the Excel sheet format. However, when you're importing the data or the exporting the data, you need to check whether you are actually, uh, copying to the correct location. So in this situation that I'm showing you in the Excel sheet, you need to get the data of mon start time instance and mon stopping time instance. So there are three mons, right? The mon 1, mon 2, mon 3. So for those mons, these are the time instances that it starts and stops, right? So for the trill also you can do the same, and you can put the trill start and trill end time. So depending on your requirement and the application, you need to decide the features that you are going to consider in your data set. So you can decide whether you are going to put each of the recordings as the input data in here, or else you consider one recording and you put all the data regarding that. That one recording has to be labeled as one single file. So maybe this is whale one recording. So regarding that, we have all this information. So the trill start and end time also we can find using the trill regions information, and that one you can also have, and we can have in here. So there's only one trill basically for 3 months. So this trill end and stopping time you can consider as the same for all these 3 records. So you can also give the type of the whale as the input data. So likewise, you can create the data set. So in here, I have mentioned data split as one column that will say what is the application of this data, whether it's used as the training data set or testing data set in the machine learning prediction algorithm. You can define it as either training or testing. So you can basically create a database using the using the data that you gathered from this signal analysis. By using this data, you can predict that after the whale has started its trill sound, what is the time at which it will start the mourn sound, and what is the time it should start. If it is not starting, then maybe there is some kind of a problem related to the whale's health or something. Otherwise, we can also use that information to predict whether an actual whale is there or not. So if we hear a trill sound at a certain time, and then if we don't see the mourn sounds occurring, then we can say that there's no whale, although we have heard a trill sound. So we need all the presence of all these components in the whale sound for it to be considered as a complete whale or a whale presence. So the presence of whales and their presence in the underground, on the underwater, has been a challenge for the sailors in the sea. So in that case, they need this prediction to check whether there are whales around in the environment. If there are, they need to just go in a certain route which is not affecting or harming them, right? So basically regarding, data set creation can be done in this manner. You can directly copy paste from this worksheet to the Excel file that you have, right? Or else you have, option of getting the variable data using a code. And actually that is more lengthy. That's very lengthy. But it actually is related to the object oriented programming. So you need to know how the objects parameters are defined and where the parameter values are defined. So based on that knowledge, you can create a code, and you can get the data regarding that record label data, right? So that actually is can be done using a sample code, and that code will give you the values of the labels. But I believe that once you have a table created like this, you can directly take it from the table in this workspace for data set creation. Basically regarding data set creation, that would be it. So if you have any questions up to now, can you let me know? I think I have taken a lot of time, but I had to get up to this point. Okay, so with regard to the task that I'm giving today, I will ask you to generate the data set related to the whale sound that uh, you can you can that you can study. I will give you some sample recordings of whale sounds. I want you to generate a data set just like this for all the whale sounds. And then maybe you can think of an algorithm that can be used to predict um, the the time instance that the specific moan sounds are occurring. That is one possibility. Second possibility is that you can use that data to predict whether there's a whale or not, whether there's a whale in the environment or not. So I will give you some data that does not have the presence of whale inside them. That means that the sound signal relates to something else. It is not related to whales. So using that data and the other data that has the whale sound in it, you can predict whether there's a whale in that environment or not. So that is basically the idea behind the prediction. So for that, first you need to make the data set. After you make the data set, you can do the rest of the prediction, maybe using the Python machine learning algorithms that you learn in the other session. So I think for the moment, I will give you this, task of creating the data set for this whale sound prediction and whale presence prediction. I will, share the task with you. If it is okay with you, I will share the task by early tomorrow morning. Will it be okay with you?
Yeah, sure, madam.
Okay, so thank you. So by, I think, tomorrow morning by about 9 a.m., I will provide you the task in a certain file, and I will share with the organizing committee. Then I think it will be possible for you to access it. So, so that is regarding the, task at hand. So if you have any other questions, please can you let me know? So with regard to saving the data into CSV file, you can use the command CSV write. So the CSV write command can be used. So you can further look into it on your own, I believe. So since this is the last session of MATLAB, I want you to know that for any issues related to the MATLAB, you can refer the um, site which is MathWorks. In there, you can actually get any support for any problem that you have. So the syntaxes that are used are given in this site. When you're searching in the Google also, you can search MathWorks and how to do this in MATLAB. So once you do that, some sample syntaxes will be generated. So they will provide you the support to implement that function, right? So normally I don't try to memorize command functions. I normally go to help, and you can get the idea regarding each of the function and how it works using the help. So the CSV write and its definition are given in here. So you can I think you can save a certain metrics or a certain metrics and its values of the metrics into a file using this CSV write command. You can read the values using CSV read. So likewise, there are some functions and their definitions you can find using the help function, help command. So with that, I would like to end today's class. So the session. So thank you so much.
Thank you, madam, for sharing knowledge and make the session much more valuable. And madam, we are ready with a small token of appreciation.
Okay, thank you.
Please accept this with our most heartful gratitude.
Thank you so much.
Okay, once again, thank you, madam. There's a kind reminder, we are having our last session on tomorrow at 7 p.m. Hope to see you guys on there. Now I would like to invite Yuvanika Samaravikrama, the project secretary, to deliver the vote of thank. Yuvanika, the virtual stage is yours.
Thank you, Dita. Good evening, everyone. I stand before you today with deep gratitude in my heart to express my sincere thanks for your participation in the InspiHER version 2 MATLAB sessions. I extend my deep appreciation to our special speaker, Dr. Vishaka Basnayaka, a lecturer at Department of Telecommunications at SLTC Research University. Ma'am, your gracious presence and two-day dedication to us are truly appreciated. If any mistake were made during your time, please accept our sincere apologies. And my fellow participants, I wish to convey my heartfelt thanks for your active engagement and participation. As we finish phase 1 of MATLAB session series tomorrow, I am grateful for the collaborative learning experience we have shared. Once again, I extend my sincere thanks to each and every one of you, and participants, hope to see you all tomorrow. Thank you.
Before conclude the session, we request all of you to switch on your cameras to take a group photo. You can use the virtual background we've dropped in the chat box. We'll give you 2 minutes to get ready and let's take the photograph. Okay, thank you everyone. Now it's time to conclude this session today. Thank you everyone for joining us and wishing you a success journey on ahead. Have a nice day. And I'm Udita Silva signing off as the moderator for the day. Thank you.
Thank you so much.